third part for this chapter 13 on alkene, alkyne, and aromatic compound. We're going to look at the type of organic reactions. They look complex, but actually they are not. Addition reaction is when you are going to have here a substance that is added to a double or a triple bond, will break that bond, and you're going to have here the product will have the X and the Y attached to the carbon. Remember, carbon need to have 4 covalent bonds. So if it goes to a double bond, this is the first example, and if it goes to a triple bond, you need 2 times X and Y so they can go on each of those carbon atoms. Elimination is pretty much the reverse, where you're going to subtract, eliminate X and Y from 2 carbon atoms that have 4 covalent bonds and insert instead a double bond, a double covalent bond, and on the side X and Y by themselves. Substitution is actually when you have an atom or a group of atoms in a molecule that is replaced by another set of atoms. So just general formula AB plus C will be substituted to give you AC plus B, also 2 different products. And finally, a rearrangement reaction is when you have a molecule that undergoes a reorganization of its bond to just give you an isomer. You need a catalyst, such here sulfuric acid. You go here from the first molecule on the top, and it will go and give you cis-2-butene trans to butene. Don't worry, I'm not going to give you example with just finding out the result, but I may ask you a question about the different type of organic reactions that take place. Most of them are going to be addition reaction for the carbon-carbon, multiple bonds. And when you look at this, this is the result you could have, just showing you again, you have addition reaction. Now, one of the applications, very important, is what we call hydrogenation. Hydro for water, and actually hydrogen atom, sorry. Hydrogenation is going to be when you break a double bond, such as the one you find in alkene, or a triple bond, the one you find in an alkyne, and you had here some hydrogen molecule, or 2 of them. You also need a catalyst to speed up the reaction. And then you go back to having just single bonds between the carbon atoms. Why is that important? You're going to understand that better when we study the saturated fats and the unsaturated fat. This is what we use commercially to convert unsaturated vegetable oil that won't be usable because they are liquid into hardest one, the one we have such as in margarine, cooking fat. And there's a lot of scrutiny about this because that's what creates the so-called trans fatty acid, and we do know today that they are not healthy. Okay, so when we look at those reactions, and this is when you have halogen. So halogen, you need to know those can be bromine or chloride, so just there's a few of them you should know. What happens in that example, same thing, you're going to have the breaking up of the double bond, and you're going to have just a single bond between the 2 carbon atoms and then the halogen that will be attached to them. Now there is a rule, it's called Markov-Nikov's rule, and this is when you look at halogen and you want to see what is the major product that arises from that hydrogen that's going to be attached to the double bond. The rule is pretty simple. Here, when you look at this, you see on the far left in red, there are no hydrogen on this carbon, so that is where the bromide will attach itself, Br. On the right side, you already have 2 hydrogen atoms, so you're going to put a third one that's going to attach to each other. If you happen to have an equal number of hydrogen atoms attached to that double bond, so in other words, it's a symmetrically substituted double bond, both possible products are formed in pretty much the same amount, so that's a 1-to-1 ratio. You'll have here the 3-bromopentane and the 2-bromopentane as the result. And when you go finally about addition of water to the alkene, that's what we call hydration. Sorry, before I say hydrogenation is hydrogen. No, hydration is when you add a water molecule. If you're hydrated, it means you have water. Still in the catalyst, such as sulfuric acid, you can still use the Markovnikov's rule to predict the product when you have the water that is added. So in other words, you're going to have the hydrogen atom that's going to attach itself to the carbon that has the maximum amount already of hydrogen atom. Well, in that example, they have a carbon linked to two hydrogen on both sides, so it doesn't really matter. And what you have at the end is what we call ethyl alcohol.